So a very good afternoon everyone. Myself Prateek Mishra and I welcome you all to the YouTube platform of IMS Gate Academy. I hope you are enjoying all the previous lectures of the foundation series that we conducted for environmental engineering. My dear, environment is one of the very important subject if I talk about gate examination and also for other technical examination for civil engineering conducted across the year. So better you understand the basics and based on these basics you try to develop the most better concepts that you can have for environmental engineering. It's one of the very easy subject and the best part is it is a practical application based subject. So whatever you read in environmental engineering you actually see it in day-to-day life. It actually happens around you. Okay. So environmental engineering has four parts as I have already told you: raw water engineering, wastewater engineering, air pollution and solid waste management. In the previous session, I have told you something about trickling filter and biological treatment. In that series only, we will continue today and our topic for today is the activated sludge process, one of the very key area from where regular questions are asked in environmental engineering. Usually students have a lot of doubts that what is actually happening in activated sludge process, how the things are going, what are the different treatment units, what is the different what are the names of the different parameters. There are so many parameters in activated sludge process which creates a lot of confusion. Today's session will be totally oriented to simplify things first. Second, to give you an understanding how to approach any question if framed from activated sludge process. So stay tuned till the last so that you don't have any doubt in the basics of activated sludge process. One more thing, my dear student, here in the foundation series, we are only dealing with the basic things. Okay. That basic will be used to develop the advanced concept from where questions will be asked. But without knowing the basics, you cannot understand the questions asked. Forget about the solution, you cannot even understand what is actually asked in the question. So try to watch all the videos of this series, especially whatever I have taken for environmental engineering, because each and every video is well designed and it is properly given to you in the form of a packet or a gift from IMS Gate Academy. Okay. So before starting this session, my dear, I would like to make few announcements. First announcement is regarding our Telegram group. If you want to have the lecture PDFs, YouTube session schedules, if you want to know about the different job vacancies that are coming for civil engineering, we regularly post our videos in our Telegram group. Okay. We also post the daily quizzes on the Telegram group, so you can join the Telegram group. The link is given in the description box. Next, my dear, we at IMS Gate Academy, we provide you with 4 different types of courses: online program, offline program, hybrid program and the self-learning program, where we provide you with 800 hours of live teaching with interaction. We provide you with theory and exercise book containing more than 4,000 practice questions, well versed in level 1, level 2 and level 3. We provide you the exclusive GATE question bank, one of the comprehensive study material to prepare for GATE examination containing 34 years of GATE question, in which we have provided the detailed solution, alternate solution, video solution along with key points and chapter overview. We provide you with 12 personalized one-to-one mentoring sessions so that you are proper oriented, proper planned and motivated throughout the journey of GATE preparation. Last, we provide you with India's largest test series containing more than 130 plus tests, which starts from the chapter test, subject test, multiple subject test, advanced subject test and the full length mock test along with the video solution. So these are some of the key features of IMS Gate Academy and we look forward to help you in your GATE preparation and the journey of the technical examination. So with these words, I would like to start my today's session. My today's session will be for the activated sludge process. First of all, my dear student, activated sludge process is a biological treatment unit. And as soon as I say it's a biological treatment unit, it means whatever treatment is happening inside the activated sludge process will be conducted by microorganisms. It is as simple as that. So activated sludge process is a biological treatment unit. So it is a biological treatment unit. It is a biological treatment unit. It's a biological treatment unit. And as soon as I say it's a biological treatment unit, it means treatment is carried out by microorganism. Treatment is carried out by microorganism. Treatment is carried out by microorganisms. Carried out by microorganisms. Treatment is carried out by microorganism. Can somebody tell me this biological treatment unit or biological treatment is used to remove which impurity? Do you remember I have told you in this previous session? This biological treatment is used to remove which impurity? Specifically which impurity? Can anybody tell me in the comment box? This biological treatment is used to remove which impurity? Can someone tell me this in the comment box, that which impurity is removed using biological treatment? We have basically three different types of impurities: suspended inorganic solids, suspended organic solids, and dissolved organic solids. Suspended inorganic solids are removed by grit chamber. Suspended organic solids are removed in the primary sedimentation tank. Now we are left with dissolved organic solids, which are removed using biological treatment. So basically, activated sludge process removes dissolved organic solids. It removes dissolved organic solids. Dissolved organic solids. So activated sludge process removes dissolved organic solids. Okay. Now how this activated sludge process is carried out? You see this. So in the activated sludge process, you have one aeration tank like this. This is your aeration tank of the activated sludge process. Now understand how this activated sludge process is carried out. So you have one aeration tank. Ahead of the aeration tank, you have one secondary sedimentation tank. This is your secondary sedimentation tank. Ahead of the aeration tank, you have secondary sedimentation tank. So now what is happening? The wastewater from the primary sedimentation tank is entering into the aeration tank. This is the wastewater which is coming from the primary sedimentation tank. It is entering into the aeration tank. All the decomposition of the organic matter will take place in this aeration tank. All the decomposition of the organic matter will take place in the aeration tank. Now, after decomposition has happened, biomass is formed. This biomass along with the wastewater is taken into secondary sedimentation tank. Right. Now, this secondary sedimentation tank is responsible to remove that biomass. Process is very simple. You have taken the wastewater from the primary sedimentation tank into the aeration tank. It's a part of activated sludge process. Okay. Inside this aeration tank, microorganism will carry out the decomposition of the organic matter and will lead to the formation of biomass. Now, along with the wastewater, this biomass is taken to the secondary sedimentation tank where it is removed. So, in the aeration tank, like here only your decomposition will be taking place. And in the secondary sedimentation tank, biomass will be removed. So, I will write down all the things. So, this is your aeration tank. This is your aeration tank. What is the process that is taking place in the aeration tank? Decomposition of the organic matter. Decomposition of the organic matter takes place in the aeration tank, and this decomposition leads to the formation of biomass. These decomposition of organic matter leads to the formation of biomass. Now this biomass is removed in the secondary sedimentation tank. So this is your secondary sedimentation tank. This is your secondary sedimentation tank, also denoted as SST. This secondary sedimentation removes the biomass from the wastewater. Removes biomass from the wastewater. Removes biomass from the wastewater. Now, what will happen in this secondary sedimentation tank is, this is the wastewater that is filled here, right? This is your wastewater which is filled. Whatever biomass is present in this wastewater, it will going to settle at the bottom of the secondary sedimentation tank. So this biomass will going to settle at the bottom of the secondary sedimentation tank like this. This is the biomass which settles at the bottom of the secondary sedimentation tank, and this settled biomass is known as the sludge. This settled biomass is known as the sludge. Now my dear, biomass contains active microorganism. Means whatever sludge that you will get from the secondary sedimentation tank will also contain active microorganism. That is why this sludge of the secondary sedimentation tank is known as the activated sludge. This is known as your activated sludge. This is known as the activated sludge. Again, I will repeat myself why it is known as the activated sludge. Biomass is taken into the secondary sedimentation tank and it is settled out. This settled biomass is known as the sludge. Since this settled biomass contains active microorganism which can further carry out the decomposition of organic matter, that is why this sludge is termed as the activated sludge. And this is your activated sludge process. Now what happens is, this activated sludge is recirculated back in the aeration tank so that the sufficient availability of microorganism is maintained in the aeration tank to carry out the decomposition of organic matter. Some portion of this activated sludge is recirculated back into the aeration tank so that sufficient availability of microorganism is maintained in the aeration tank to carry out the decomposition. Okay, so I will write here. Some portion of the activated sludge is recirculated back in the aeration tank to maintain sufficient availability of microorganisms to carry out the decomposition. carry out the decomposition, right? So these are some of the very important basic regarding your activated sludge process. Okay. So I hope this is clear to you. This is your wastewater from primary sedimentation tank. Wastewater from primary sedimentation tank. Okay. This is your wastewater from primary sedimentation tank. Again, I will going to repeat myself quickly. Wastewater from the primary sedimentation tank is applied to the aeration tank where sufficient availability of microorganism and oxygen is maintained. In the presence of oxygen, microorganisms carry out the decomposition of organic matter in the aeration tank to form biomass. This biomass is taken to the secondary sedimentation tank where it is settled out. That settled biomass is known as the activated sludge. Reason being, this settled biomass contains active microorganism. In order to maintain sufficient availability of microorganism in the aeration tank, some portion of this settled sludge or the activated sludge is recirculated back in the aeration tank. Okay, so these are like 4 or 5 key points regarding the aeration, regarding this activated sludge process. Now you see here in this aeration tank, microorganisms will be present in suspension, and you have also maintained the sufficient availability of oxygen in this aeration tank. Sufficient availability of oxygen is maintained in the aeration tank. Sufficient availability of oxygen is maintained in the aeration tank, and also the microorganisms will be present in suspension like this. Microorganisms will be present in suspension like this, and sufficient availability of oxygen is maintained in this aeration tank. Therefore, this activated sludge process is termed as aerobic suspended growth system. It is termed as aerobic suspended growth system. So I will just write down few key points. First of all, activated sludge process is a activated sludge process is a aerobic suspended growth system. It's a aerobic suspended growth system. Next point. Microorganisms carry out the decomposition of organic matter in the presence of oxygen in the aeration tank. In the aeration tank to form biomass. Okay. Now next, biomass is settled in the secondary sedimentation tank. Biomass is settled in the secondary sedimentation tank. Settled biomass contains active microorganisms. Settled biomass contains active microorganisms biomass contains active microorganisms, hence it is termed as activated sludge. Hence it's termed as activated sludge. And I have already written that some portion of this activated sludge is recirculated back to the aeration tank in order to maintain sufficient availability of microorganism in the aeration tank. So these are the key 4 points regarding the basics of activated sludge process. Now after this, the next topic of discussion is when the water is flowing inside the aeration tank, what are the different flow patterns? What are the different flow patterns that we can provide inside the aeration tank? Okay, the first flow pattern is known as, so different types of flow pattern that happens inside the aeration tank are, first one is known as plug flow. The first flow pattern inside aeration tank is termed as plug flow. Now see what happens in plug flow. So this is my aeration tank, right? This is my aeration tank and you have allowed the wastewater to enter from this side. The wastewater is entering from this side. The wastewater is entering from this side, right? Now this wastewater will move as it is, without any mixing. If this wastewater keeps on moving like this, without any mixing, if this wastewater keeps on moving like this, without any mixing, if this wastewater keeps on moving like this, if this wastewater keeps on moving like this, right? This is termed as a plug flow. So what is the characteristic thing about plug flow? In plug flow, there will be no mixing of the wastewater. There will be no mixing of the wastewater. The wastewater will flow as it is, like this. Like this. It will flow like this. There will be no mixing in the plug flow. So plug flow does not have mixing. It does not have mixing. It does not have mixing. The first property about plug flow is it does not have mixing. If you just allow the water to enter into the aeration tank, so simply the water will flow like this without any mixing. Okay, second point. In the plug flow, in the initial portion of the aeration tank, the amount of organic matter will be more, right? In the initial portion of the aeration tank, in this initial portion of the aeration tank, in this, or I should say entry or initial portion of the aeration tank, the amount of organic matter will be more, okay? Because organic matter has just entered into the aeration tank and now the decomposition of the organic matter will start. And as this wastewater will move from inlet to outlet, the decomposition of the organic matter will happen. Due to this reason, at the entry or on the initial portion of the aeration tank, the amount of organic matter will be more. As this wastewater has travelled along the length of the aeration tank, then on the exit portion, the amount of organic matter will be less. In the initial portion, amount of organic matter is more. Reason is decomposition has not started. But as this wastewater will travel from entry to exit, here on the exit side, the amount of organic matter will be less because some organic matter have been already decomposed. So on this exit portion, the amount of organic matter will be less. So here I will write down more organic matter. More organic matter, and here less organic matter. organic matter and less organic matter. Okay. I'm just giving you the basics so that you have an idea. Based on this, we will going to define several other parameters that you can define when you read that in the properly when you read it. But this is just the basic to give you an idea to define the other parameters. I am not giving you the parameter, okay? I am not giving you the parameter. I am just telling you when the wastewater will going to enter, there the amount of organic matter will be more in the entry position or in the entry segment, and on the exit segment, your amount of organic matter will be less. So when the wastewater is traveling in the aeration tank, along the length, the amount of organic matter decreases. So as the wastewater travels in the plug flow, as the wastewater travels in the plug flow, along the length of the aeration tank, amount of organic matter decreases. Amount of organic matter decreases. Amount of organic matter decreases. As the wastewater travel along the length of the aeration tank, the amount of organic matter decreases. Okay, now coming to the next thing. Okay. As you can see here, there is no mixing of the wastewater taking place. Therefore, the chances of the microorganism to come in contact with the organic matter is less. The chances of the microorganism to come in contact with the microorganism is known as contact opportunity. So, contact opportunity is a parameter which tells us about what are the chances of microorganism to come in contact with the organic matter. If the contact opportunity is less, it means the chance of microorganism to come in contact with the organic matter is less. So, in the plug flow, contact opportunity is less. Means the chance of microorganism to come in contact with the organic matter is less since no mixing is induced. So, I will write here, since no mixing is induced, therefore, chance of microorganism to come in contact with the organic matter is less. So, this is the first type of flow pattern that can happen inside the aeration tank of the activated sludge process, which is termed as the plug flow. In plug flow, simply the wastewater will travel without mixing. In the initial portion of the aeration tank, your organic matter will be more. In the later portion of the aeration tank, your organic matter will be less. As your wastewater will travel along the length, the amount of organic matter will reduce. Since no mixing is induced, therefore the contact opportunity of the microorganism to come in contact with the organic matter will be less. So, this is the first type of flow pattern. Obviously, the efficiency of treatment that we get from the plug flow will be more, but the rate of removal, that is the amount of wastewater you can treat with the plug flow, will be less. Efficiency will be more because this wastewater stays in the aeration tank for more time. That is why the decomposition of the organic matter takes place properly. But the amount of organic matter, that is the rate of removal, amount of organic matter that can be treated using the plug flow will be less. Okay. Now coming to the second type of flow pattern. The second flow pattern is known as complete mix. The second flow pattern is known as complete mix. This flow pattern we are talking about, this flow pattern will be present inside the aeration tank. So second flow pattern in the aeration tank can be complete mix. Now see what happens. So you have this aeration tank. In this aeration tank, there is mixers which are present. Mechanical mixers are present like this. Like this you have mechanical mixers present. Mechanical mixers are present like this. These mechanical mixers rotate like this, and when wastewater is applied to the aeration tank, these mechanical mixers will going to completely mix the organic matter with the microorganism. These mechanical mixers will going to completely mix the organic matter with the microorganism. Now due to mixing, what happens is the contact opportunity of the microorganism with the organic matter increases. The chance of a microorganism coming in contact with the organic matter increases. Okay. If the chance of microorganism to come in contact with the organic matter increases, means the amount of wastewater that you can treat in a day will going to increase. Okay. So in complete mix, mixing of the wastewater or mixed liquor takes place. Mixing will take place. I'll write like this. Mixing will take place. Next, chance of microorganisms to come in contact with the organic matter, is more. Now next thing, it's a complete mix, means this entire mixed liquor, entire wastewater is mixed. So whatever organic matter and microorganisms we are talking about, they will be uniformly distributed throughout the entire volume of this aeration tank. All the organic matter and the wastewater and the microorganism will be uniformly distributed in the entire volume of this aeration tank. Due to this complete mix, organic matter and microorganism will be uniformly distributed in the entire volume of this aeration tank. So I will write down, due to complete mix, organic matter and microorganisms will be uniformly distributed in the entire volume of the aeration tank. In the complete volume of the aeration tank. in the complete volume of aeration tank. In the complete volume of the aeration tank, right? So here if a statement comes that along the length of the aeration tank in a complete mix, the amount of organic matter, option A, increases, option B, decreases, option C, remains same, option D, cannot be said anything. So your option C will be the correct option, where you will going to mark that the amount of organic matter remains same along the length of the aeration tank. It will not going to vary along the length of the aeration tank. It will be uniformly distributed throughout the entire volume of the aeration tank. So these are the two flow patterns that can exist in the aeration tank. First one is the plug flow and second one is your complete mix. Now after this, my dear, let's see the proper mechanism of activated sludge process. We will going to see all the different parameters that we use, which actually creates a lot of confusion. Actually, it is very easy. It is actually very easy to understand all the parameters if you keep a check on the flow pattern of the activated sludge process. And also, if you keep a check on the different activity that is taking place in the activated sludge process. So let's see one by one. So can you quickly tell me what is the first unit that we have in the activated sludge process? What is the name of this first unit that we have in this activated sludge process? Can you quickly tell me? What is the name of this first unit that we have in the activated sludge process? So after this first unit, we have this second unit of, after this first unit, we have this second unit in the activated sludge process, right? This first unit is known as the aeration tank. So this is my aeration tank. And then you have secondary sedimentation tank. In short, I will write down as SST. Now see, the wastewater from the primary sedimentation tank is entering into the aeration tank, okay? The discharge of the wastewater that is coming from the primary sedimentation tank is Q naught. Every term is important, right? Usually because using these terms, it creates a lot of confusion for you. So what is the amount of discharge that is coming from the primary sedimentation tank to the aeration tank? It is Q naught. In this wastewater, the suspended solid concentration that is present is SS naught. And the BOD of this wastewater is S naught. S naught is the BOD of the wastewater which is entering into the aeration tank. SS naught is the suspended solid concentration that is coming along with the wastewater into the aeration tank. Discharge of the wastewater that is coming into the aeration tank is Q naught. Okay. The volume of this aeration tank is V and the concentration of biomass is X inside the aeration tank. Now I have told you this in the previous session. Whenever I need to tell the concentration of microorganism, I tell it using biomass. Biomass is expressed as mixed liquor suspended solid MLSS or mixed liquor volatile suspended solid. In the either way you can represent the biomass, okay. So that MLSS or MLVSS is X. X is basically the amount of microorganisms which are present in this aeration tank. Now these microorganisms will carry out the decomposition of the organic matter, and this organic matter now have been decomposed and the value of organic matter is S. The amount of organic matter that entered into the aeration tank is S naught. After decomposition, the amount of organic matter that is left in the system is S. S naught is entering. After decomposition, the amount of organic matter left in the system is S. Okay. Now this wastewater is taken to the secondary sedimentation tank from the aeration tank, like this. It is taken to the secondary sedimentation tank from the aeration tank, right? Now here what will happen? In the secondary sedimentation tank, what will happen? In this secondary sedimentation tank, the biomass that has entered into the secondary sedimentation tank, that will settle out. There will be no change in the amount of organic matter. Okay. Whatever biomass, so here the biomass which is entering into the secondary sedimentation tank is X. Out of this X, some portion will going to settle out. So this is your settled biomass. This is your settled biomass, and this settled biomass is termed as the activated sludge. This settled biomass is termed as the activated sludge. Okay. This settled biomass is termed as the activated sludge. Now from here, the wastewater is taken for further treatment, right? From here, this treated wastewater is taken for further treatment. Sometimes tertiary treatment, and if tertiary treatment is not given, this wastewater is disposed of. Okay, now see here. X is the mass of biomass which is entering, amount of biomass which is entering into the secondary sedimentation tank. S is the amount of BOD present in the wastewater which is entering into the secondary sedimentation tank. This secondary sedimentation tank will not treat any amount of BOD. It will only going to settle out this biomass. So the amount of BOD that will be coming out with the wastewater will be S. The amount of BOD that is coming out with the wastewater is S. Okay. Now we are talking about this activated sludge. This is my activated sludge. This is my activated sludge. We take out the activated sludge, right? We take out this activated sludge. The discharge of activated sludge that we take out is known as QW. Sorry, this discharge of activated sludge is known as QU. This is known as useful discharge. This is known as useful discharge. This is known as useful discharge. In this useful discharge, the amount of biomass that is present is XU. In this useful discharge, the amount of biomass present is XU. And in this useful discharge of activated sludge, BOD will be S. Because this secondary sedimentation tank does not treat any BOD. So whatever BOD that is entering into the secondary sedimentation tank, the same BOD will be present in the effluent that is coming out from the secondary sedimentation tank, and also the sludge that is taken out from the secondary sedimentation tank in the form of this useful discharge. Now out of this useful discharge, some portion of this useful discharge will be recirculated back into the aeration tank. Some portion of this useful discharge will be recirculated back into the aeration tank like this. Some portion of this useful discharge will be recirculated back into the aeration tank. Just 1 second. Some portion of this useful discharge will be recirculated back into the aeration tank. Okay, so this is the recirculated discharge. Some portion of this useful discharge QU is recirculated back into the aeration tank. Now along with this recirculated discharge, the amount of biomass which is entering or re-entering into the aeration tank is XU. Okay, and QR is recirculated back. Now QW is termed as the wasted sludge discharge. This QW is known as the wasted sludge discharge. Out of QU, QR is recirculated and QW is taken to the sludge digestion beds. These are taken to sludge digestion beds. This is taken to sludge digestion beds, or simply sludge digestion. It is taken to sludge digestion. The amount of MLSS that will go along with this QW will be XU, and the BOD of this is S. You can see here, BOD is not changing in the secondary sedimentation tank. Now see here, the total amount of discharge which is entering into the aeration tank now is Q naught plus QR. So total amount of discharge that will come out from the aeration tank will be Q naught plus QR. The total amount of discharge that will come out from the aeration tank will be Q naught plus QR. This will be Q naught plus QR. Here the biomass concentration will be S, X, and the BOD concentration will be S. Okay. Out of this Q naught plus QR, which is entering into the secondary sedimentation tank, QW is your useful discharge. Okay. So if you look into the amount of discharge that is coming out from here will be equal to Q naught minus QW. If you look into this entire system, right? If you look into this entire system, say this is your entire system. I am just giving you an idea. If you look into this entire system, right? This entire system, you will find out there are 3 points from where either the discharge is entering or discharge is moving out. So total discharge entered into the system is Q naught. Now the discharge that is moving out from 2 places, from here and from here. Okay. So if the discharge moving out from here is QW, then the discharge that will move out from here will be Q naught minus QW. Q naught is the amount of discharge entering. QW is the amount of discharge that is moving out from one point. Then from the other point, the amount of discharge that will move out will be Q naught minus QW. So this is your entire system that you need to analyze, right? And based on this system, we have written these things. So I hope you don't have any confusion in this. Okay. I will write down quickly what are the different parameters that we have. So Q naught is amount of discharge entering ASP, entering activated sludge process. SS naught and S naught is the suspended solid, and BOD concentration of the wastewater entering ASP. Respectively. V is the volume of aeration tank. V is the volume of aeration tank. Then X is the MLSS or MLVSS. In simple words, biomass concentration in aeration tank. Biomass concentration in the aeration tank. Now next, S is BOD of treated wastewater, or I should write down biologically treated wastewater. Biologically treated wastewater. Then you have QU, which is known as useful discharge. XU, it is the MLSS concentration of the activated sludge. MLSS or MLVSS concentration of activated sludge. MLSS or MLVSS concentration of the activated sludge, right? Then you have QW, which is known as wasted sludge discharge. Then you have QR, which is known as recirculated sludge discharge. So these are all the parameters that we have that we will use for defining the different parameters of activated sludge process. Okay. Usually students have a lot of confusion. What do we mean by QW? What do we mean by say QU? What do we mean by XU, X, all those things. And if the question is framed from the activated sludge process, they play the game here itself. They present the data in front of you in such a way that the student starts feeling confusion. What is written? I cannot understand. Whenever you have the question from activated sludge process, first understand what is given to you. And then you calculate the whatever thing is asked for the question. Okay. So I hope this is clear to you. So this is the entire flow diagram of your activated sludge process. This is the flow diagram of the activated sludge process, right? Now, based on this flow diagram, we have defined certain parameters for this activated sludge process. We will only going to see some of the basic parameter, okay? The first basic parameter is known as hydraulic retention time. Hydraulic retention time is defined as the ratio of volume of aeration tank to the rate of flow of wastewater. So hydraulic retention time, HRT, hydraulic retention time is defined as the ratio of volume of the aeration tank, that is V, divided by the discharge of wastewater, that is Q naught, excluding recirculation. You don't have to include recirculation here. So hydraulic retention time is simply the ratio of volume to discharge. The unit of hydraulic retention time is either seconds, minutes, or days. Hydraulic retention time also tells us for how much time the water is present in the aeration tank. So the physical significance of hydraulic retention time is this only. It tells us about for how much time the water is present in the aeration tank. Second one is known as the organic loading rate. Organic loading rate is defined as the ratio of amount of organic matter entering into the aeration tank to the volume of the aeration tank. So it is defined as the ratio of amount of organic matter entering into the system or entering into the aeration tank divided by the volume of the aeration tank. So organic matter is represented in the form of BOD. So the total amount of BOD that is entering into this aeration tank is equal to Q naught into S naught is the amount of BOD which is entering. So the amount of BOD that is entering into the system is Q naught into S naught divided by V. So your organic loading rate is Q naught S naught divided by V. Unit will be kg per meter cube per day. It is expressed like this. So this is your second parameter for your activated sludge process. Next is termed as the specific food utilization rate. Now these two parameters that I have written are very, very important parameters. Okay, first of all, a specific food utilization rate is defined as the ratio of amount of organic matter removed by the system to the mass of biomass present in the aeration tank. What does specific food utilization rate tells us? It tells us the ratio of amount of organic matter removed from the system to the mass of biomass present in the aeration tank. So one by one, let's see what is the amount of organic matter that is removed from the system. So first, organic matter is removed from here, and second, organic matter is removed from here. Okay, first one is organic matter is removed from here, and second one is organic matter which is removed from here. So the total organic matter that is entering into the system is Q naught into S naught. This is the total organic matter that is entering into the system. The organic matter which is removed is minus QW into S minus Q naught minus QW, Q naught minus QW into S. This is the amount of organic matter that is removed from the system. Entry minus exit is equal to the amount of organic matter that is removed from the system divided by the mass of biomass present in the aeration tank. So mass of biomass is equals to volume of the aeration tank multiplied by the MLSS concentration, which is V into X. When you will going to solve this, you will find that this QW into S and QW into S will cancel out. This QW into S will cancel out. And you are left with Q naught. So you can take out Q naught common. In bracket, you are left with S naught minus S. In bracket, you will be left with S naught minus S, right? So this is how the specific food utilization rate is defined. It is defined as the ratio of amount of organic matter removed from the system to the mass of biomass present in the aeration tank. Next is your sludge age. This is denoted by theta C. Now sludge age is defined as the ratio of mass of biomass in the aeration tank. So mass of biomass in the aeration tank is V into X. Mass of biomass in the aeration tank. Mass of biomass in the aeration tank, which is V into X, to the mass of biomass leaving the system per day. So the mass of biomass that is leaving the system per day is QW into XU. Biomass is leaving the system per day will be QW into XU. So sludge age is defined as V into X divided by QW into XU. So this is your sludge age. V into X divided by QW into XU, right? So this is just for the basic thing, right? Now we have one more thing which is known as, so this can be fifth one, which is known as F by M ratio. So F by M ratio is also termed as food to microorganism ratio. Food to microorganism ratio, right? This is defined for the aeration tank. Food means organic matter. The total amount of organic matter that is entering into the aeration tank is Q naught into S naught. The amount of organic matter that is entering into the aeration tank is Q naught into S naught divided by the microorganism. So the total amount of microorganism or the biomass present in the aeration tank is defined as V into X. volume of the aeration tank multiplied by the concentration of biomass. So F by M ratio is food to microorganism ratio, which is equal to Q naught into S naught divided by V into X. Okay. Next and the last is your sludge volume index. Now, what do we mean by sludge volume index? So, sludge volume index is basically calculated by taking 1 liter of mixed liquor, right? 1 liter of mixed liquor, 1 liter of mixed liquor, 1 liter of mixed liquor. Now, where this mixed liquor is present? This mixed liquor is present in the aeration tank. This mixed liquor is present in the aeration tank. So what you did? You took 1 liter of mixed liquor from the aeration tank. So this is 1 liter of mixed liquor. So this is 1 liter of your mixed liquor, right? Now this mixed liquor will contain biomass or suspended solids. Biomass also present in suspension, right? This mixed liquor will contain suspended solids or biomass. So what you will do is, you will allow this wastewater to settle for 30 minutes. Allow this wastewater to settle for 30 minutes. Allow this wastewater to settle for 30 minutes. In 30 minutes, this biomass will going to settle out at the bottom. This biomass will going to settle out at the bottom, okay? This biomass will going to settle out at the bottom like this. These biomass will going to settle at the bottom like this. Now what you have to do is, you have to measure the volume of this settled biomass and you have to also measure the weight of this settled biomass. Measure weight and volume of settled biomass. Measure weight should be measured in grams and volume should be measured in ml. This is something standard that we need to follow, right? You need to measure the weight and volume of this settled biomass. Weight should be measured in gram and volume should be measured in ml. So sludge volume index is defined as the ratio of volume occupied in ml. Volume occupied in ml. I'll write here. Sludge volume index is the ratio of volume occupied in ml, volume occupied in ml by weight of the biomass in gram. By weight of the biomass in gram. This is the weight, this is the volume. This weight and volume you need to take the ratio. Volume divided by the weight. So always the sludge volume index will be calculated in ml per gram. This will always be calculated in ml per gram, right? So this is your sludge volume index and these are some of the basic factors or parameters that we calculate for the activated sludge process. And based on these basics, we develop the activated sludge equation and then we analyze the question, okay? So I hope this session was useful to you. You might have heard this session till the end. If you have liked the session, don't forget to share it with your friends. And please subscribe to our channel for such interesting videos and for such well-defined and well-designed series. Okay. So this is all what I have to offer today for the activated sludge process. Moving ahead, last few announcements. So my dear, the link of the Telegram group is given in the description box. You can join our Telegram group to have the lecture PDFs, to have daily quizzes, and even if you want to have job notification updates, you can join our Telegram group. We at IMS Gate Academy, we provide you with 800 hours of live teaching with interaction. We offer 4 different types of program: online program, offline program, hybrid program, and the self-learning program. We will provide you the theory and exercise book containing 4,000 practice questions, well versed in level 1, level 2 and level 3. We provide you with the exclusive GATE question bank containing 34 years of GATE question, in which detailed solution, alternate solution, video solution along with key points and chapter overview is present. We also provide you with 12 personalized one-to-one mentoring session to keep your preparation oriented and well planned in the entire hectic journey of GATE. We provide you with India's largest test series containing 130 plus tests. It starts from the chapter test, subject test, multiple subject test, advanced subject test and the full length mock test along with the video solution. So thank you so much for listening patiently. I'll come back soon with the next video in the same series of Foundation of Environmental Engineering. Till then, take care and have a nice day. Thank you so much.